Gabby, thank you very much for chatting with me about this topic of plant-based foods and how to make them more delicious than they are already. Before we dive into the science, I wanted to get to know you a little bit and understand why it is that we're here, what brought you here. So I guess let me start with what brought you to food science. How did you get here?
I always wanted to do something with biology, and then I went to Germany to study bioengineering. And I thought I was going to do something with enzymes and pharmaceuticals, and then I realized I'm not patient enough for this kind of things. And I looked around what can also be done in the field of bioengineering, and I heard a lecture about food science and food technology, and it really clicked with me because the first part was about how food has moved beyond hunger and nutrition, but it's a key part of society. Like you eat in special moments as a ritual, you use food to bond, you use food to indulge and enjoy some occasions. And this really helped me to find a way to match what I was doing in a technical manner with society and how can I influence or have a contribution to society from the science point of view without being able to cure cancer, but
Right,
also
right.
bring joy to people.
Of course, yeah, I think that's very important. So I have young children. My daughter's 2 and my son is 4. And one of the things I read tons of parenting books and look at all the accounts on Instagram and social media. And one of the most important things is, well, one is reading, but the other one is to make sure you eat together to really to raise them well and to make sure that your family remains close and healthy. So that's very interesting. So I guess then what brought you to Thermo Fisher? Like what kind of things did you study and how are you using some of those things that you studied and worked on to what you do here at Thermo Fisher?
I work as an application specialist at Thermo Fisher Scientific for over 3 years now, and I specialize in extrusion. This is a unit operation that is widely used in the food industry to create different textures. And the thing about texture is one of the sensory attributes that most people really look for when buying something, a product. So if the texture is not right, you're not going to buy this pack of crisps or you're not going to buy this snack, because even if the flavor is good, if it doesn't crunch, if it doesn't produce this sound that you're looking for when you bite a Dorito, then it's not satisfying. So I studied bioprocess engineering at KT, and then I specialized in food process engineering and especially on texture. So I went to texture measurements and how to modulate different food structures so they produce certain texture that is present for consumption. If you think about low-fat yogurts, they need to be creamy as well. If you think about plant-based, they have to have this anisotropic structure, like muscle-like fibers, so the consumer feels that it's real meat out of plants. So this link about texture and consumer acceptance, it was what drew me to Thermo Fisher.
Okay. And people who are listening and not looking, you put the quotes around real meat, quote unquote real meat, and that's something we'll talk about later. Just as far as, especially in this topic of plant-based foods, plant-based proteins, the quote unquote real meat or imitation meat versus something that more resembles, I guess, a vegetable or a whole food. But we'll get to that later. So we're talking about science and texture and how we experience food. How, I guess it's hard for me, and I'm sure a lot of people, to understand how can scientific instruments measure how something is experienced in the mouth and ultimately on someone's fork or plate.
This is a very good question. It's still a research topic, actually, and it's one of the most interesting ones for me, at least. So, sensory perception of texture, when you think about texture, is actually three things. Is how you interact with your food in a visual way. So you look first at the surface and the color, so you can say how the texture is without touching it. So is it smooth? Is it rough? How is the color? It is shiny, glossy. Then how you handle it. So are you able to spoon it or spread it um, without too much resistance? And then when you bite it, the first bite and how it behaves in the mouth. So these all things, this combination of sensory perceptions give you information of texture. It's really hard just to pinpoint to one attribute and say, this is a good texture and this is bad. But we can always measure forces. So every interaction with the haptic and the mouthfeel is a force that we apply as human beings with our oral cavity or with our hands. And the food is giving a resistance toward this force. And this is something objective that we can measure. So, of course, we need to prove that these values, or which values are in the range that we feel is okay. So that's why we always need panelists in a sensoric panel to validate our results. But it makes for us food scientists the work easier, because then we can measure things faster and put a value to it without asking a lot of people, is this good or is this bad?
In a way, that sounds kind of fun. And when you mention that there's the instrument, the scientific instrumentation makes a measurement of these sensory attributes, and there's a panel of humans evaluating or validating this. It reminds me of, I don't know if you ever watch these cooking shows where someone cooks something,
Yeah.
and then the people are like, oh, I don't know, this is too salty or it's too soft. So it reminds me very much of that. And even though I'm making it kind of silly, but that's seriously, in a way, a similar purpose of kind of validating and saying, well, the instrumentation did a good job. And as scientists, what your community does is try to make things as close to perfect as possible by studying previous mistakes, making your own mistakes, doing better. So that's very interesting. So I know one of the instruments that you work a lot with is the rheometer. So I guess in simple terms, what is that? And then how does it help you with measuring some of those sensory attributes?
Maybe I'm not the best person to describe a rheometer, but I apologize beforehand to all my rheologist colleagues that maybe I'm going to cringe when I talk about this.
Uh,
So a rheometer is a device to measure the resistance of a fluid or a semi-solid product. So you can measure viscosity, so the flow behavior of these materials, and the deformability of these materials. So this is the rheology part, but the food science part is that you can measure different forces. So, for example, you have a sensor for a normal force. So you can compress samples with a certain velocity and a normal force, so you can mimic the chewing behavior of
a
humans.
person. Yeah.
So person. So you can mimic chewing. You can use different accessories to imitate the tongue and the palate. and put your sample in it so you know how it lubricates to create different mouthfeels. So, for example, something that is described as creamy is usually a good lubricating agent because it has oils or different proteins. Or if it's something that is not really good homogenized, it could be rough and sandy. So the friction within these two accessories is going to be higher. And of course, you can determine different gelling properties. For example, for low-fat products, when you need to reduce the amount of fat, then you lose viscosity. So you need to add other ingredients to compensate for this. So you can check the viscosity and check at which temperatures then you have a gel or not. So it's a really multifunctional tool to describe all textural properties of food. And there are values that are fundamental, like the viscosity, that are not only for the sensory acceptance important, but also for production, like for pumping, filling, and so on. And there are other measurement techniques that you can use also with a reometer that are imitating, so the chewing behavior. So you can imitate something that humans do when they consume food.
So you mentioned some of the lubricating, like the fats and things like that. I would imagine that that comes into play with, well, animals have a lot of natural fat, and that's a lot of it's fairly solid at room temperature and things like that. And plants, some not as much. It's not as much the case there. So I would imagine that rheometers helps with kind of perfecting that plant-based protein if someone's trying to mimic the mouth experience of an animal protein, right?
Yeah. For example, when you have dairy alternatives, so you have a normal whole milk pudding and it's rich in fat, animal fat, and you want to produce something that is equally creamy and enjoyable, but out of plant proteins, then you need to match the lubricating properties of the fats and the proteins to get the same creamy mouthfeel. And oftentimes, this dairy alternative is perceived as too firm or too sandy because they don't have these special lubricating properties that the animal fat and animal proteins have.